Anyone who could tell me? Okay, what did you learn last meeting regarding with the Charles Law? Okay, volunteer? Oh, yes, Nathaniel. I know that you're thinking and you want to answer. You may.
Ano po, just recall po, right? We talk about Charles' law po, and it is about how temperature and volume are directly proportional to each other po.
Okay, very good. So it talks about Boyle's law, and according to Nathaniel, it is the relationship of temperature and volume. And according to him, it is directly proportional. What else? Any other? Ay, Charles law pala. Sorry, sir. Yes. Okay. So what else? Carl, Justin.
About po the different formulas po to solve.
The different formulas. Okay. So what are the different formulas? Huh? Yes, Cyril. Mama, Cyril? Class number 37?
The Charles law is the formula of Charles law is
Sorry po. Okay, go Cyril.
T sub 1 times V sub 2 is equals to V.
It's okay, don't be shy.
So,
It's really like that. That's the
T sub 1.
reality. Okay, thank you so much, Sai. Yeah, keep on smiling, no? Okay. Tell to your mom to lessen the voice. Okay. So, next. What about you, Ren Santos? Hi, Renz. Renz, what did you learn from the Charles Law last time? I cannot see your face, only your eyes and then your hair. Would you mind to lower down your camera, Renz? Okay, go, Renz. What have you learned from the topic Charles Law? Aside from that is temperature and volume relationship and it is directly proportional plus the formula. What else?
I said that's my answer.
Come again, Renz?
That they are proportional po, sir.
Yeah, that they are proportional or directly proportional. Yes, Eric, you want to raise your hand? Eric? Tamot ulo ah. Eric, only that one?
The formulas po.
Yes po. Oh, go. Drop the formulas.
V1 is equal to V2 times V1 over T2. And V2 is equal to V1 times T2 over T1. V1 is equal to V1 times T2 over V2. And T2 is equal to V2 times V1 over V1.
Okay, very good, Wens, no? So, but what will be the general formula for Charles Law? Anyone? Yes, Jake.
Sir, almost the same as in Boyle's law, but there is like D sub 1 multiplied by D sub 2. That equals D sub 2 and D sub 1.
Okay, thank you so much, Jake. So, always remember, with that formula, if we're talking about Charles Law, temperature must be converted into Kelvin. Okay? You have to remember that one, ha? Okay? So, this time, let us have, Kevin already submitted, if I'm not mistaken. Submitted already the activity. Very good, Kevin. I hope next time you will not be late. By the way, the one that we talked last time, if you are late, it will be, or you will receive a deduction from that point. No? Okay? So, let's now proceed. So, we're done with the Boyle's law, and we said from the Boyle's law, it is inversely proportional. We're done with Charles' law, we said the Charles' law, that is directly proportional. What about this third gas law? allow me to present this one. So this morning, what we will discuss is all about the Lussac'S Law. Okay, or what we call the pressure-temperature relationship. Okay, so who did it propose this Lussac'S Law or Lussac'S Law? Anyone? Yes, Ian. Who proposed Lussac'S Law? Okay, so the one who proposed Lussac'S Law is Joseph Lussac, according to Gian. And according to Lussac'S Law, it is stated that, yes, Aldea,
Relationship of pressure and temperature is also like directly proportional.
very good. The relationship of the temperature and pressure is directly proportional. Okay, so Guy Lussac's law states that at constant volume, the pressure exerted by a given sample of gas is directly proportional to its absolute temperature in Kelvin. So remember, in Guy Lussac's law, if we're talking about temperature, we need to convert still this one into Kelvin. Okay? So we said that the volume that the pressure and temperature are directly proportional. What do you mean by that? So it means that, yes, Jody. Jody, what do you mean by directly proportional? According to the statement in the Guy Lussac's law, temperature and pressure are directly proportional.
Sir, can you hear me po?
Yes po.
Okay po. So, for me po, the definition of directly proportional is that no quantities are in the same direction or in constant po.
Okay, in the same direction or in constant. Okay? So, meaning to say, if the temperature increases, what will happen to the pressure? It will increase also. Okay? On the other side, if the temperature will decrease, then what will happen to the pressure? It will also decrease. Okay? So, let's proceed. Next. Next slide is the one that we're telling. Do not be confused with the word pressure even though it's going up. Still, you have to look at the arrow. Excuse me. Okay? So, as the temperature decreases, what will happen to the pressure is decreases also, or it will decrease. Then on the other side, if the pressure increases, then what will happen to the temperature will also increase. Now look at this one. Here is the general formula for the Guy Lussac's law. P1 times T1 is equivalent to P2 times T1, where P1 is our pressure 1 and P2 is final pressure 2 or final pressure, while the T1 is the initial temperature and T2 is the final temperature. And always remember, in Guy Lussac's law, the temperature must be converted into Kelvin. Gets? Question. Okay, so I hope you do already the screenshot with the Guy Lussac's law. Now, look at this figure in the Guy Lussac's law. This is another style of putting the formula aside from that general formula. We have P1 over T1 is equivalent to P2 over T2. Okay, and here P is or pressure is directly proportional to the temperature. Okay. So next, so here is the graph if we're talking about directly proportional. So this is the example, okay, or this is the graph itself really, if it is directly proportional. As the pressure increases, then the temperature will also increases, then vice versa. Okay, so here also, as you can notice here in this figure, no, if the temperature is decrease, then what will happen to the pressure? Look at the movements of the molecules. So it is a bit slow. But if you will put the fire, or if you will put the fire into high, then what will happen to the molecules of the water will move very fast. Okay? So that's it. Now, let's go already with the general formula. Again, with the general formula. So we have P1 times T2 is equivalent to P2 times T1. If the unknown is P1, then how are we going to find that one? Huh? Allow me to use my second camera. Please wait. So going back to the general formula, this is our general formula a while ago. P1 times T2, okay? So P1 times T2 is equivalent to P2 times T1. Now, if P1 is unknown, what will be the formula if P1 is unknown? Yes, Abby.
P, P sub 2 times T sub 1 over T sub 2.
Very good. So P1 is equivalent to P sub 2 times T sub 1 over T2. Okay. What about if let's go with the P2. P2 is unknown. What is the formula for P2? Yes, Madeline. If P2 is unknown, what will be the formula?
Can you hear me po?
Yes.
It's P sub 1 times
T
T
sub
sub 2
1 times T sub 2
over T sub 1 po. All
T
over T
sub.
sub 1.
Very good, Madeline. Okay. Next, what about T1? If T1 is unknown, what will be the formula? Yes, Chloe. P sub. Very good, Chloe. And the last one, if T2 is unknown, the formula will be, yes, Neil, acid. What will be the formula for T2? Hello, Neil. The number you have dialed is either unattended or overshare. There. Come again, Neil. I cannot hear you properly. Neil, my question is, what is the formula for T2? I cannot see your face, only your head. Okay, I'll go back to you later on. No, Maynard, what's the formula for T2?
Formula for what, sir? T2?
T2.
P sub 2 multiplied by T sub 1 all over P sub 1.
Very good, Maynard. Okay, so that will be the formula for T2. T2 is equivalent to P2 times T1 all over P1, while T1 is equivalent to P1 times T2 over P2. And we have P2, that will be P1 times T sub 2 over T1, and P1 is P2 times T1 over T2. Any question? Did you do already the screenshot with this formula? Huh? Okay, so let's get it on. Let's try the problem solving regarding with the Lussac'S Law. So the first problem is this one. Okay, can you read this one, Rancap?
Determine the pressure change when a constant volume of gas at 100 atm is heated from 2.0 degrees Celsius to 30 degrees Celsius.
Okay, so according to the reader, no? Determine the pressure change when a constant volume of a gas at 1.00 atmosphere is heated from 20.0 degrees Celsius to 30.0 degrees Celsius. Now, what are the given problem in problem number 1? Yes, Antoinette, can you give me the different given?
1 ATM. I mean, 1 point
1 ATM is, what is that?
pressure sub 1.
Okay, pressure sub 1 or P sub 1. What else?
20 degrees Celsius.
Okay, 20 degrees Celsius. That will be,
Um,
what is that?
temperature sub 1.
Okay, T1. And next will be,
30 degrees Celsius.
okay, very good. 30 degrees Celsius. That will be our
Temperature sub 2.
temperature sub 2. Okay. Now, in this given, as you notice, we have P1, T1, and T2. So, what will be the unknown here? Huh? Yes, Carl. The unknown is
P2 po.
P2. Okay. And what is the formula for P2, Carl? P2 is equivalent to what? Carl, formula for P2?
P1 is sub to P2 over T1.
Again, P1 times
P1 times T2 over T1 po.
T2 over T1. Very good, Carl. So, the formula is P2 is equivalent to P1 times T2 over T1. Is it visible, the one that I'm writing? Please let me know if you can see this one. If you can. Okay, so how are we going to do next? Can we substitute already the value? Huh? Huh? What's the next one? Excuse me. Convert into Kelvin. Very good, Gian. We need to convert the temperature into Kelvin. Oh, if we will convert the 20 degrees Celsius, what's the value in Kelvin? Anyone? You can use your microphone. Yes, Francesca. What's the value of T1 in Kelvin now?
293 Kelvin po.
Okay, we have 293 Kelvin. What about for our T2? T2, may I hear the voice of Chanel?
303 po.
Okay, 303 Kelvin. Can we substitute now? Is it all correct? Our T1 and T2, is that your answer also? Okay, we can now substitute the given. So P1 is 1.00 atmosphere multiply with our T2, which is 303 Kelvin, all over, okay, what is our T1? 293 Kelvin. At this point, before we proceed with the computation, we need to cancel the Kelvin. Then that's the time that we will do the operation. And then compute 1.00 times 303 times divided by 290. What is the answer? You can put your answer in the chat box if you don't want to talk. Okay, the correct answer is, I think most of you, okay, we have 1.03 atmosphere. So very good. You're following the general rules of Sir Alex in putting the decimal point, no? So 2 decimal places. No? Oh, what, Denzel, what is your answer, Denzel? What is that one? You're having slash. So congratulations to all students who submitted their answer here in the chat box. Okay, so now I know that you are on the right track. Now let's proceed to the given problem number 2. Okay, here is the problem number 2. May you read this one? Roy, please read number 2 problem.
A container of gas is initially at 0.500 atmosphere and 25 degrees Celsius. What will the pressure be at 125 Celsius?
Thank you so much, Roy. May I call on John Marlon Labares? What are you given in the problem number 2?
Ano po, 0.5
Hello po.
ATM.
Come again?
You can hear me po.
Yes, 0.5
5 ATM.
500 atm. What is this 0.500? Okay, that will be pressure 1. Next, what else? Then we have 25 degrees Celsius. This is T1. What else? Okay, we have 125 degrees Celsius. So what is unknown in this problem? Huh? The P2. P2. P2 again. My goodness, always P2. Come again, what's the formula for P2? Ralph Rodrigora, may I hear your voice? What's the formula for P2? Ralph, you want to remove in this Gmit? Huh? Okay. May I hear the voice of Luis? Luis, what's the formula for P2? That's already our example a while ago. So I think they are not talking.
Sir?
Here, Luis. Luis, what's the formula for P2?
The formula for P2 is P1 times T2 over T1.
Over T1. Can we substitute already the value? Neil, can we substitute already the value this time?
No, sir.
No, why? What's the reason why we cannot substitute the value this time? Neil?
Because you need to convert the Kelvin.
Okay, very good, Luis. Because you need to convert first the temperature into Kelvin. Now, Princess, what's the value for T1 if we convert this one into Kelvin?
298 Kelvin.
298 also. Wow, the same. What about the T2? 125. Princess?
398 Kelvin for T2.
398 Kelvin for T2. Can we substitute already this time, Princess?
Yes po.
Okay, let's proceed. Our P1 is 0.500 atm. Let me know if you can see my handwriting. If you cannot see, please let me know. Okay, multiplied with our T2, which is 398 Kelvin, all over with our T1, which is 298 Kelvin. So what we will do next, before we proceed to the operation, cancel first the Kelvin. Then proceed to the operation, 0.500 times 398. Okay. Divided by 298. And the answer is, what's the answer? For P2, the answer is, wow. Okay, to Francesco, 0.67. Kevin, 0.66. I told you, in the hundreds place, you need to round up the hundreds place po. Okay. So the correct answer is 0.67 atmosphere or atm. Sure, 0.66 is correct. Yes, but again, the rules of Sir Alex, the hundreds place in a decimal point must be round up. Okay? Any question with Charles Law? Charles Law, sorry. Any question with the guy Lussac'S Law? Question? Who among you are still confused with the formula? It's clear? Okay, let's have another example. Okay, this is another example for 10A. Example number 3. Okay, and so please read the given.
The given are 47.98 mmHg.
Read the formula rather.
Okay. What?
The formula, sorry. The given problem.
Sige po. A gas container is initially at 47 mmHg and 17 Kelvin. What will the
What is
pressure
mmHg?
I forgot now.
I forgot. So when we say mmHg, that is, Kate, what is mmHg?
Millimeters of mercury.
Very good. Millimeter of mercury. That's how you will read. Okay? So a gas container is initially at 47 millimeter of mercury and 77 Kelvin, which contain liquid nitrogen temperature. What will the pressure be when the container warms up to room temperature of 25 degrees Celsius? Okay? So still they're asking for pressure at this moment. Proceed, guys. You can compute first that one. I will not be the one. Okay? Those who are off the camera, please turn on so that I can see you and I can recognize you. Okay, finish. Who among you are done already in sample problem number 3? Okay, some of you answer 181.90 millimeter of mercury. Okay, I hope all of you are solving, my dear people of the Philippines, ha? Not that you will just copy the answer of those who answered in the chat box. Okay, let me see the computation of Caitlin. Is it, sorry, Pauline? Is that class number 29? Pauline, correct?
Pauline po.
Yeah, you're done,
Ah,
Pau?
no po.
Not yet. Okay, go. Proceed. You can solve first. Let me hear or let me see the answer of um, Mackenzie. Mackenzie, may I see your computation? Okay, you can show here in the camera your computation, Mackenzie. Boom. Very big. I cannot see the handwriting. Okay, there. Okay, very good. Now, explain to us your computation.
Hello, sir. Can you hear me?
Yes.
Okay, so the first thing I did was to find the missing term in the problem, which was P sub 2. After determining the missing, I would get the given, which is P sub 1, T sub 1, and T sub 2. For P sub 1, it is 47 millimeter of mercury. P sub 2 is missing. T sub 1 is equivalent to 77 Kelvin. T sub 2 is equivalent to 25 degrees Celsius, which I will convert to Kelvin. So that is 273 plus 25, which is equivalent to 298. The formula, if P sub 2 is missing, is equivalent to P sub 1 multiplied by T sub 2 all over T sub 1. I will substitute the terms, and that will be given to 47 millimeter of mercury times 200 298 Kelvin all over 77 Kelvin, cross out Kelvin, and then I will use the calculator to determine my answer, and the answer that I got is 181.896, or rounding off to the hundredths place, which is 181.90 millimeter of mercury.
Very good. I thought you will forget the unit. Oh. Don't forget the unit. Okay? So, let's give 5 virtual claps to Mackenzie. Come on. Very good, Mackenzie. Okay? Well expressed the answer. Okay? Congratulations. Correct. So, the correct answer for example problem number 3 is 181.90 millimeter of mercury. Sir, can I leave po? I will change my device. Go, Lara. Okay? So, at this moment, let's proceed already with the sample problem number 4. And the one who will answer this one is, let me see, those who are not yet talking, Gab Biteng will be the one to answer. That is representative for the boys. And the one for the girls will be, who's the one? Jello. Jello class number 24 will be the one to present the answer. Okay, but all of you, I want to see your answer in the chat box. Okay. Practice solving, because next week, if it is offline, more quizzes, more fun. Okay, let us answer. Shall we answer? You can put your answer in the chat box. Not yet done? Once again, you can put your answer in the chat box. 3.31 according to Pawi, Kate, Gian, Zara, Madeline, Carl, Kevin, Maria, Cyril, Denzel, Aldea. Okay, let me hear. Who's the one that I called a while ago? For the boys, I forgot already. The only
Me
thing
po.
that... Okay, proceed. Who's that one? Gab?
Yes po. The first thing that I did is find
Gab,
the
may you show first your answer in the camera?
It's kind of scrambled po kasi. Dikit.
Gab, ang bilis naman. We did not see.
Dikit sa ilaw.
Okay, there. Okay.
The first thing that I did po is find the given. For P1 po is 3 ATM and for T1 it's 20 Celsius and P2 is 70 Celsius and the missing is P2 and the formula is P1 times T2 as all over T1 and we have to convert the Celsius to Kelvin. So for T1, 20 Celsius is equivalent to 297. What? 293 Kelvin po. And for T2 is 343 Kelvin. Then we have to go for the formula. So 3 ATM times 293 Kelvin is all over 343 Kelvin po. And we have to cancel the unit for Kelvin, then the answer is 3.31 ATM.
What's the unit? Gab, there. You almost forgot the unit. So 3.31 ATM. And our representative for the girls will be, who's that?
Me po, sir.
Okay, you may proceed.
This is my solution. It's messy. Okay, the given is P1 is equal to 3.00 ATM and P1 is 20 degrees Celsius. P2 is 50 degrees Celsius. P2 is missing. The formula is P2 is equal to P1 times T2 over T1. First, I convert the 20 degrees Celsius to Kelvin, which is 293 Kelvin, and then 50 degrees Celsius to Kelvin again to equals 323 Kelvin. So I substituted it to the formula, which is P2 equals to 3 ATM, 3.00 ATM times 323 Kelvin all over 293 Kelvin. I cancel out the Kelvin unit and then my answer is 3.31 ATM.
Very good, Jello. So 10A, people of the Philippines, let's give 5 virtual claps to Jello and to Gab. Very good. Nice one. Okay. So we still have 6 minutes. Oh, sorry. 5 minutes already. Now, I want you to screenshot the next slide, no, so that you can answer this one. I was up to 11:50. I remember, if I'm not mistaken, no, 11:50. Still have. Okay, you can answer this one. Okay, sorry, not number 2. This is number 5 already. Okay. This will be the problem. Okay. This answer. Then the next, do first the screenshot and then I'll give the other one. So that later on, as in 1, you will put the answer in your chat box as in 1, 2, 3. Okay, next will be this one. Okay, do the screenshot. Done? Okay, finish. Okay, next will be this one. This is the last actually. Sorry, not anymore. That's only two. Okay, later on is the application already. Okay, please answer. Then later on, I hope after 4 minutes, we can have already. The first one who will present the answer is, let me call on Maria Tabita. Okay, and then, sir, I'll turn off my camera first. Okay, go Enzo. And then the second one who will present the answer is Nathaniel. Which number first we will answer? The first one. Okay, two. That one. This one first, then after that, the second one. So you need to put two answers in the chat box. Then the second one, the second problem will answer by Jordan. Okay. Gets? Any questions? So you have two problems to answer, huh? Okay. Proceed. So this is the first one. Okay. Later on, I'm going to move with the second slide. Then if you have question with the computation and you're having hard time, please let me know, huh? It should be open to all so that I can give you some remedial class regarding with this computation. Because in your periodic exam, of course, it will be thunderstorm for the gas loss, no? Just like what I told you, if you're done, you can put your answer in the chat box. Okay. For the first one, we will put the answer. No, for problem number 1 and problem number 2, will receive plus 1 point in the quiz. Very fast that one. 1 point. Sir, 1 point only. Of course. The first one, make sure it's correct with unit. So you put already two answers here in the chat box if you answered. So that you will receive 1 point in the quiz. Wow, Gabero, very fast. Let us see if your answer is correct, Gab, ha? Okay. Shall we start answering already? Because I think some of them are done. Who's the assigned person in problem number 1?
Sir, I'm not done po. I forgot to convert. Sorry.
Okay. What about for number 2? You're done, you're done? Hi,
Yes,
Jordan.
po.
Come again?
I am done.
Okay, go Jordan. You may present already your answer for number 2 and let us check. May I see your answer?
Number 2 po or number 3?
Number 2. Lower down your camera. I cannot see your face.
Yes po.
Come on, 10A ha. This time you're becoming shy in showing yourself already to Sir Alex. Okay, thank you so much. Please do the honor to explain your answer. Sana all with aircon while having the online class.
Can you hear me po?
Yes, Jordan.
For number 2, P1 is equals to 0.370 atm. P1, 91.0 Celsius. P2 is equals to 273 Kelvin. The missing is P2. The equivalent of P1, you will convert Celsius to Kelvin. P1 plus 273 is equals to 364. Then you will compute 0, 0.37 atm times 273 divided by 364 is equals to 0.277 atm. And we will round off the hundred, what do you call it? It is equals to 0.2 atm.
And the answer is?
Ay,
Jordan, what's the answer?
0.28 atm po pala.
So you answered the first one. Okay. What about in the second one? Okay. Class number 10? Ay, sorry, 10A, that one. What's this one? Maria Tabita, you're done? Okay, go. You may answer the second problem.
Second po.
Yes.
Sir, didn't finish that one po eh.
I did not. So how was that one? Okay, anyway, let's call another volunteer for problem number 2. Problem number 2, may I hear the voice of Carl? Carl, go. You may present your answer for problem number 2. Go, Carl. Hindi naririnig. Carl, you may show first in the camera your answer in problem number 2. Would it be possible? Yes po, you'll be the one.
Ano po, I don't know if it's visible po ba, the number 2 po ba?
Okay, thank you. Go, proceed and explain.
So I'll go ahead with the missing one, which is P2. For my formula, of course, wait lang po. So, P1 is equals to 0.370 atmospheres, and T1 is equals to 91.0 degrees Celsius. And then since for my T2, since as it says, it is the standard temperature, which is 0. Degrees Celsius. First, we convert the temperature into Kelvin. So 91.0 degrees Celsius will be 364 kelvins, and then the 0 degrees Celsius will also be 273 kelvins. Since I already proceeded to my answer, it's 0.370 atmospheres is times to 273 kelvins, which is all over 364 kelvins. So I got the answer as 0.28 atmosphere because of rounding of the answer.
Okay, thank you so much, Carl. Very good. Next. Okay, second problem, the one that is projected. So most of the answer is 0.28. Roy Banyares. Roy, would you mind to share your answer for number 2? First, Roy. Hello, Roy.
Hey po, sir.
Go. May I see your answer?
Ano po, sir? I'm
Ano
not
po?
sure of my answer po.
For number 2? Oh, you just tell to your friend
Yes po.
later to call. Oh, go. It's okay. May I see? What's your answer in number 2?
It's ano po? It's 634.24 po.
24. Oh, it's okay. Go. Present your answer.
Well, this is my answer.
Don't be shy.
This one. This one po. Kita ba?
Okay, then please explain how did you get the 634.24?
What I did is the 750.0 mmHg, I multiplied it with 273.15 Kelvin, and I divided it in 323 Kelvin, and that's why I get 634.24 mmHg.
Okay, so very fast, ha? Most of super shortcut, Roy. Okay, congratulations. The correct answer for number 1 is 0.28 atmosphere, and the second one is 634.25 millimeter of mercury. For those who answered here, no, please, no, okay, I'll just put stop so that up to Jordan Clyde, they will receive 1 point. All of them who put the answer in the chat box, starting from, who's the first one? Gabero. Starting to Gabero, then the last one is to Jordan Clyde. They will receive +1 in the quiz because they put their answer in the chat box. Okay? So please, ha? Can you do the screenshot and post it in our stream in the G Classroom, the one who answered here? Would it be possible? Please do the screenshot, ha? You do your screenshots here so that if for example, you got 18 in the quiz and you want to be perfect, or 19 in the quiz and you want to be perfect, just show to me this one that you are part of the +1 point and show me that your name is included in this chat box, then you will get already the 1 point. Gets? So I hope next meeting will be our offline quiz. No? Mostly Boyle's Law, Charles' Law, and Graham's Law. Then, would that be possible if we will have online again next meeting? Would it be possible to prepare your whiteboard and then whiteboard marker so that if I will ask you to explain your answer, that is the one that you're going to present to us? Would that be possible? whiteboard and whiteboard marker during online class in Science 10, please prepare. If not, what you will do is to use pentel pen and bond paper so that it's visible to your classmate what is the one that you are explaining for. Okay, because we're visualizing only the one that you are telling because very small your handwriting. Anyway, class number 3. Thank you so much, by the way, ha. 10A, you're very good, no? I can see that most of you are turning on the camera. So please, 5 virtual claps to all the 10A. Congratulations, job well done. And I hope it will be consistent up to fourth quarter. Because in Tagalog, kapag nababate, the second one, nagpapatay na ng camera eh. So sana wag mabales, no? So it will be continuous. Okay, so let's proceed already with our prayer. Class number 3, Abila. Is Abila around? Go, proceed.
Then the Father, the Son, the Holy Spirit, and bless us all, Lord, and this time gift in which we are about to receive from thy bounty through Christ our Lord. Amen. Father, the Son, the Holy Spirit.
Okay, before we end this one, may I request, oh, Labares already out, left already, maybe the other account. Would it be possible, can you do the screenshot of this picture and then post it in the Google Stream of the 10A? One picture only you can post as part of the attendance. Okay, ready? Please turn on your camera.